All right, good day, everybody. Wherever you are, I'm so happy and I'm so excited to be bringing this to you. It's a very, very big package from CMRC, Creative Mind Real Concept. And I'm most privileged to be the innovator, the initiator of this program. It is a very, very big success to bring this to you. Free Success Project 2025. And this year, I am so happy. We have amazing facilitators, persons who are selfless, who are passionate, who are explicit in every ramification of their discipline, and they will blow your mind. So I want you to keep your tabs and start watching these videos and get excellent results and come back to tell us, and we'll rejoice with you. God bless you.
Good day, everyone. I welcome you back to the next episode of our chemistry tutorial. So now I'll be giving you some basic things that you need to know even before going to your examination, or which will help you. I'm not here just to come and teach or lecture you. No. So what I'm here to do is that to give you some things that you really need that will be very important for your calculations when you get to the section of chemistry. So today, what are we doing? This is what we are doing, redox reaction. So it's a very important and interesting topic in chemistry. So, and then it's very important because it has its biological parts. Because in your body, as a human being, there are redox reactions going on in your body. So you have buffer solutions, a lot of things going on in your body. So now, in this place too, we have redox reaction. So what is redox reaction? It's a mixture of two things, reduction and what? Oxidation. So this red is for reduction, reduction, and this OX is for what? Oxidation. So both reactions occur simultaneously. Occurring simultaneously means that what? They are occurring at the same time. So wherever you see oxidation, that means that what? Reduction is also occurring. So wherever reduction is occurring, that means oxidation is also occurring. Now, let's define terms. What's oxidation? Oxidation is the process of what? Electron loss. That's the simplest definition of oxidation you can ever find. Oxidation is the process of what? Electron loss. So oxidation is the process whereby electrons are being lost. To reduction, which definitely will be the opposite. So reduction is the process of what? Electron gain. So reduction is the process of gain of electrons. So oxidation is the process of electron loss. Reduction is the process of what? Electron gain. So simple. Now, there are other definition of oxidation, and then for oxidation now, another definition of oxidation is that oxidation is the process of addition of oxygen. From the word oxidation. So when we say something is being oxidized, so we are saying that what? We are adding oxygen to the thing. For example, now the combustion of fossil fuels, the combustion of carbon. Let's say you have carbon C plus O2 to give CO2. This is a kind of oxidation. You are adding what? Oxygen. That's oxidation. So in another way, oxidation is the increase in oxidation number. So when a substance increases from a lower oxidation number to a higher one, that's what we call what? Oxidation. For example, let's say you have Cu, okay, let's say Cu2 plus 2E minus to give, okay, this is not oxidation. Let's say you have something like 2Cl minus to give Cl2 plus 2E minus. Looking at this, once you have a charged species like this, the oxidation number is equal to the charge it carries. So in this sense, this Cl minus here, it has oxidation number of -1, but because of these two at the back, it is what? -2. And then this one, because it's normal chlorine, neutral chlorine, so it is not bonded to anything. It has oxidation number of what? 0. So -2 and 0. 0 is greater than -2 by magnitude. So we have between -2 and 0, 0 is greater. That means this substance is being oxidized because there is increase in what? Oxidation number. So when you find a substance whereby oxidation number before is 1, and then it now increases to 4. So from +1 to +4, that's what? Oxidation, increase in oxidation number. Also, the fourth point, oxidation is also the process of addition of electronegative elements. So when you add electronegative elements to a species, you are what? Oxidizing that thing. For example, now let's say you have H2 plus Cl2. You are directly combining hydrogen and chlorine. So here, chlorine is an oxidizing agent. It's also an electronegative element. In fact, it's the third most electronegative element. So if you are adding chlorine to hydrogen, that means you are adding an electronegative element to another thing. That's what we call what? Oxidation. Also, oxidation is the process of removal of hydrogen. So oxidation is the process of removal of hydrogen. So as you remove hydrogen from a species, you are what? You are what? That means you are oxidizing it. So I've made 5 points. Oxidation is the process of what? Electron. Oxidation is the process of electron loss. Oxidation is the what? Addition of oxygen. Oxidation is the removal of hydrogen. Oxidation is the addition of what? Electronegative elements. And also oxidation is what? Increase in oxidation number. So you can even tell me what reduction is. It's just the opposite of everything I said before. So reduction will be the process of what? Electron gain. Reduction will be the what? Removal of electron. Reduction will be the what? Addition of hydrogen. Reduction will also be what? Removal of electronegative elements. Likewise, reduction is also what? Reduction is also decrease in oxidation number. So when the oxidation number of a substance decrease from a higher value to a lower value, that's what? Reduction. So when you remove oxygen from something, that's what? Reduction. When electrons are being gained, that's what? Reduction. And reduction is a property of metals. From the characteristics of metals, the normal chemical characteristics of metals are good reducing agents. That is to say, they undergo reduction. They can donate electrons. So now, let's move to oxidizing agents. Oxidizing agents are agents that are capable of what? Of performing the work of oxidation. So oxidizing agents are able to perform oxidation. So when you see a substance that can add oxygen to another thing, that substance will likely be what? An oxidizing agent. So now, what are reducing agents? Reducing agents are agents that are capable of reduction. That is to say, reducing agents can donate electrons. Oxidizing agents are electron acceptors. Oxidizing agents are electron acceptors. Reducing agents are what? Electron donors. So why are metals electron donors? Because they are what? Reducing agents. So reducing agents are electron donors. An example of oxidizing agents, we have two very common examples of oxidizing agents, very common, used in the laboratory. Number one is your manganese, MnO4. Manganese, this manganese, okay, MnO4, that's manganese, okay, KMnO4, sorry, KMnO4, potassium tetraozomanganate 7. Potassium tetraozomanganate 7. Another example of oxidizing agent is your K2Cr2O7. This is what we call potassium dichromate for short. This is potassium what? Ethaozodichromate 6. So it's another example of oxidizing agent. So when you have this substance, when you have this reagents, they are capable of oxidizing other things because they easily supply oxygen. So we have an example of reducing agent too. Reducing agents, number one, examples are like metals. Metals are good reducing agents. So when you see something like aluminium, Al3 plus, aluminium, when you see something like copper, when you see something like calcium, they are good reducing agents. They are good reducing agents. So now, what is oxidation number? Oxidation number is like the valency of any element. Like the number is possessed by a certain number of rules by convention. So you have metals, for example, now, those elements in group 1, they are univalent. Why are they univalent? They have one electron in the outermost shell. So that means they will have oxidation number what? +1. So elements in group 2, they have 2 electrons in their outermost shell. That means they will have oxidation number what? +2. Like that, like that. So, but there is something you need to know under oxidation number. And what you need to know is that when you have a charged species, when I'm talking about the charged species, I'm talking about monoatomic ions, I'm talking about polyatomic ions. So when you have a charged species, for example, SO4 2-, in this charged species, we have 2 different atoms. We have an atom of sulfur and 4 atoms of oxygen. If you want to calculate the oxidation number of this kind of species, it will be the oxidation number of this kind of species is going to be equal to the what? The charge that is on top. So that means the summation of oxidation number of this of sulfur and oxygen will be equal to the what? -2 that is on top. If you have a neutral molecule, maybe something like H2O. So the summation of all the oxidation number of the species present, which are hydrogen and oxygen, will be equals to 0. So the sum of all oxidation numbers of elements present in a molecule, in a neutral molecule to be specific, is equals to what? 0. When you have molecules like H2O, CO2, KMNO4, when they are not charged, the sum of the oxidation number of everything present in those molecules is equals to what? 0. But when you have a charged species, the sum of all the oxidation number of the atoms of elements present will be equals to the what? The charge on top. So if I ask you to calculate the oxidation number of this molecule, oxidation number of, like, okay, let me say oxidation number of sulfur here, it will be what? S plus, you have 4 atoms of oxygen, 4. Then what's the oxidation number of oxygen? Oxidation number of oxygen in most compound is -2. I know by now you should know that. It's -2. It will be equals to what? -2. This 2 minus on top. -2. And that will what? X plus 8 equals -2. S equals to -2. So S minus 8, sorry, equals to -2. So S equals to -2 plus 8. S equals to what? Plus 6. When you are writing oxidation number, always put the charge in front, whether plus or minus. So you can't tell me that S is equals to 6 here. You might find this as an option in your JAMB. If you pick it, you are wrong. It must be plus. Plus must be in front. Plus must be in front. So now, let me now give you the rules that guide oxidation number. Number 1 rule is that the oxidation number of a neutral element in its uncombined state is 0. The oxidation number of a neutral element in its uncombined state is 0. Let's say you are talking about chlorine molecule, Cl2, oxygen molecule, O2, or you are talking about just calcium, Ca. When they are not combined with anything, when they are on their own, the oxidation number is what? Is 0. The oxidation number is 0. So imagine you have something like this. You have something like C plus O2 to give CO2. This carbon here is uncombined. It's just there. It's just alone. So that means the oxidation number of carbon here is what? 0. Then this oxygen is the oxygen molecule. Is there, it's not combining with anything. That means the oxidation number will also be what? It will also be 0. When they are not combined with anything, the oxidation number is what? Is 0. So another rule is that when you have oxygen in most compound has oxidation number of -2. In most compound, oxygen has oxidation number of -2. Then for hydrogen, it has oxidation number of +1 in most compounds. Hydrogen has oxidation number of +1 in most compounds. And then the sum of oxidation numbers of atoms of elements present in a molecule is equals to 0 if the molecule is neutral, if it is not charged. And then is equals to the charge if it is a charged species. So for example, if you have something like KMNO4, the sum of all the oxidation number of everything present, which are potassium, manganese, and oxygen, will be equals to what? 0. But if you have something like MnO4 minus, the sum of oxidation number of everything present, which is what? Manganese and oxygen, will be equals to what? -1. -1 is the charge on top. So for these two compounds, let us calculate the respective oxidation number of manganese. You can have KMNO4 and then MnO4 minus. Now, potassium is in what? Group 1 in the periodic table. That means it has oxidation number of what? +1. So this one is what? +1. One calculates oxidation number of manganese, +1 plus oxidation number of manganese plus this one is oxygen, 4 atoms, 4 into what? The oxidation number of oxygen in most compound? -2. Will be -2 equals to 0. So you are going to have +1 plus Mn minus 8 equals to 0. Mn equals to what? 8 minus 1. Mn equals to what? +7. So the oxidation number of manganese here in this compound is what? +7. Now let's go to the second one that is charged. MnO4 minus. Because MnO4 minus is the ionic form of KMnO4 is in the solution. So now it will be Mn plus 4 into oxidation number of oxygen -2 equals to the charge. Because it's charge, this one will be what? -1. If this one were to be 3 minus, it will be equals to what? -3. But it is minus, so that's what? -1. So you have Mn, this Mn minus 8 equals to -1. That is to say, Mn equals to -1 plus 8, and then Mn is equals to what? +7. So the oxidation number of manganese, both in its ionic form and in neutral molecule in KMnO4, is still +7 +7. So if they give you any question that you calculate oxidation number, you must know that the summation of everything, if it is a neutral molecule, will be equals to the what? 0. But if it is a charged molecule, it will be equal to the charge on top. So there is this question that I saw under oxidation. They gave compounds like HCl, HOCl, HOCl3, no, HOCl, HClO3, HClO4. The question says that they should calculate the oxidation number of chlorine in each of the compound. So how do you do it? First thing you should notice that all these compounds, they are just what? They are neutral molecules. They are not charged. That means the sum of oxidation number of every atom present in the compound will be equal to what? 0. So for HCl, it will be what? We want to calculate the oxidation number of chlorine in HCl. That will be what? For hydrogen, it is +1. That will be +1 plus Cl equals to 0. And then Cl will be what? -1. So for this place, oxidation number of chlorine here is what? -1. So in this compound, HOCl, oxidation number of chlorine, how do you do it? For hydrogen, it is +1. That will be +1. For oxygen, it is what? Oxygen is -2. That is +1 plus -2 plus Cl equals to 0. That means +1 minus 2 plus Cl equals to 0. That means chlorine is equals to what? That will be what? 2 minus 1. That's what? +1 in this case. You can calculate for each and every one of them using this principle and you will get it. So that's what oxidation and reduction is all about. So now I want to tell you that in electrolysis and in electrochemical cell, we use this principle of redox reaction because basically in electrolysis and electrochemical cells, what occurs is what? Redox. That's what? Reduction and oxidation. Now let me define electrolysis. For electrolysis is like the chemical decomposition of an electrolyte. Emphasis on an electrolyte in molten states. So electrolysis is not decomposition of a chemical compound when it is in solid state. No. For electrolysis to occur, the compound that is the electrolyte we are talking about must be in what? Molten or aqueous form. That's the form in which it can break into ions. So electrolysis is the chemical decomposition of a compound in molten or aqueous state when electricity is passed through it. So when you have an electrolyte and then there is passage of electricity into the electrolyte decomposes and breaks down into ions. But if the electrolyte is in solid state, electrolysis cannot occur. So the main thing or the prerequisite to electrolysis is what? The electrolyte must be in molten state or must be in aqueous solution. So they can ask you that which of the following is true about electrolysis. 1, that electrolysis occurs when the electrolyte is in solid state or when it occurs in liquid state. The answer is that the electrolyte must be in what? Molten or aqueous form, which is the liquid state, for electrolysis to occur. So now, what is an electrolyte? An electrolyte is a substance that, when in molten state, it decomposes, it breaks down into ions by the passage of electricity. So an electrolyte breaks down into ions by the passage of electricity only when it is in molten or aqueous form. So they can ask you a question that which of the following is an electrolyte? They now put aluminium, they put solid sodium chloride, and then they put aqueous potassium chloride. Which one is the answer? It is aqueous potassium chloride, because although sodium chloride can conduct electricity, it can only conduct electricity when it is in molten form. So beware of the molten and then what? The aqueous form. So it is only when an electrolyte is in molten form or aqueous form that it has the capability of conducting electricity and then break down into ions. So when an electrolyte is in solid form, it cannot conduct electricity. So now let's move to electrochemical cells. What are electrochemical cells? Electrochemical cells are cells that convert chemical energy into what? Electrical energy. There are cells that convert chemical energy to electrical energy. So those are the cells that you use in your normal day-to-day activity, your Tiger battery. For those of you that use radio at home, that Tiger battery that you put inside your radio, that battery that is inside your remote, your remote control. For those that play keyboard, that battery used in your keyboard, those batteries that after using for a number of days, you dry them in the sun and then after some time, you discard them. So those are electrochemical cells. So they are chemical cells, they use chemical energy to produce what? Electrical energy. And then one thing that is peculiar to them is that their reaction is what? Spontaneous. Their reaction is spontaneous. So We have electrolytic cell, we have electrochemical cells. So there are differences between the two. The first difference is that for electrolytic cell, electrical energy is converted to chemical energy. For electrochemical cell, chemical energy is converted to what? Electrical energy. So, and then another thing for electrolytic cell, in electrolytic cell, the negative electrode is the cathode, while the positive electrode is the anode. But in electrochemical cell, the negative electrode is the anode, while the positive electrode is the cathode. Know this point. Meanwhile, in both electrodes, normally electrodes are rods that connect the electrolytes in such a way that they allow movement of ions to move from the anode to the cathode. So electrodes are basically of two types. You have the anode, you have the cathode. But there are some electrodes that we have like, okay, active and inert. Active electrodes are electrodes that influence discharge of ions in solution, while inert electrodes are electrodes that do not take part, they do not influence discharge of ions in solution. So an example of an inert electrode is platinum. An example of inert electrode is platinum or graphite electrode. They are inert. They do not influence discharge of ions in solution. They are just there normally to convey ions from the electrolyte, from the anode to the cathode. Anode like that. But for active electrode, that means they can take part. That means they can influence the kind of ion that is being discharged in the solution. So an example of an active electrode is mercury electrode. Mercury electrode, it influences the discharge of sodium ion, the influence of sodium ion to form what we call sodium amalgam. So in your normal electrochemical cell, you can see if you use a mercury electrode and then you are using something that has to do with sodium in your solution, that means it will influence the discharge of what? Sodium ion. So you have active, you have inert electrode. Inert, they do not participate. They do not influence. But active, they play a big role in what? Influencing the kind of ion that is being discharged in your what? In your electrolysis. So I've talked about the differences between electrolytic cell and chemical cell. Meanwhile, at the anode, oxidation occurs. At the cathode, reduction occurs. That is constant for both cells, whether in electrolytic or in electrochemical cell. Oxidation occurs at the anode. Reduction occurs at the cathode. And then what is reduction? Process of electron gain. What is oxidation? Process of electron loss. So at the anode and cathode, you have a form of this nature. At the anode, you have something like this, X minus to give X plus E minus. At the cathode, you have something like this, X plus E minus to give what? X. To give X. Let me say X solid. Now, look at this place. Don't forget I told you that at the anode, there is what? Oxidation. What's oxidation? Increase in oxidation number. Now, what's the oxidation number of this one? X minus, based on what I've told you before, if you have a charged species, the oxidation number is equal to the what? The charge on it. So if this is X minus, that means the oxidation of X here is what? -1. This one, X is just standing. It is uncombined. It is neutral. Don't forget the first rule I gave to you in the rule of oxidation numbers, that when you have a substance or an element in its uncombined state, its oxidation number is what? 0. So here you have X is not combined with anything. Oxidation number is what? 0. So -1 to 0, that's increase in oxidation number, and that's what? Oxidation. That's what occurs at the anode. Now, at the cathode, look at this. This one is also a charged species. What's the oxidation of X here? +1. Because it's charged, so the oxidation number is equal to the charge on top. Now, this one is not combined with anything. It's just there. The oxidation number is what? 0. So from +1 to 0, that's reduction in oxidation number, decrease in oxidation number, and that's what? Reduction. So at the anode, oxidation takes place. At the cathode, reduction takes place. The only difference between an electrolytic and electrochemical cell with respect to the electrode, with respect to the cathode and anode, is that in an electrolytic cell, cathode is the negative electrode, while in electrochemical cell, cathode is the positive electrode. However, that does not change the fact that reduction occurs at the cathode, both at the electrochemical and at the what? Electrolytic cell. Now, let me talk about defect of electrochemical cells. I've told you that electrochemical cells, they convert chemical energy to electrical energy. That's what can power all those things that you use. Your torch, you have electrochemical cell there. So The other different types of electrochemical cell, we have Leclanche cell, we have Daniel cell, and we have West Crimson cell. So those are electrochemical cells. They are known as primary cells. They're also known as primary cells. So primary cells cannot be recharged. That's why you see that when you use your remote control, your battery that you put inside your remote, once the battery is dead, you cannot go and charge it. You dispose it, you discard it. They are not rechargeable. They are not rechargeable. But you have some secondary cells. They are also part of electrochemical cells. We have secondary cells. Those cells, they can be recharged. Those are one of those cells, the cell you find in your car battery, your lead acid accumulator. So when the battery is dead, you can take it to a panel, like all those battery chargers, they can charge it for you. So the difference between primary and secondary cells is that primary cells cannot be recharged once they are used up, but secondary cells can be recharged once they are used up. However, both of them are under electrochemical cell. So let me talk about defects of primary cells. Defect of primary cells. Don't forget, primary cells are under electrochemical cells. So the reason why your battery dies and you can't use it again, what makes it to die? No, number one thing is there's something we call local action. And there's something we call polarization. Polarization. So those are the two defects of primary cell, the two basic types. Basic defect of primary cell. Now, what is local action? Local action is the wearing away of the electrode, of the cathode of your primary cell. It begins to wear away. What makes it wear away? Like after it is in solution, you just see that it begins to reduce in size, keeps reducing, and the time comes whereby it gets exhausted. And then see, in as much as one electrode gets exhausted, it cannot work again because the other electrode needs the cooperation of the second electrode for there to be electricity. That's what local action is all about. And then how can you prevent local action, or how can you correct it? Is by galvanizing or by plating your electrode. Now, polarization. Polarization is another defect of primary cell. Polarization is the production of hydrogen bubbles around the cathode of your cell. So when hydrogen bubbles are being produced, they block the electrode from contacting with the electrolyte, thereby bringing about no movement, bringing about no kinetics of the ions. So how do you prevent that? You can prevent or correct polarization by using some oxidizing agents, which we call depolarizers. Example is your potassium permanganate. This KMNO4. KMNO4 will supply oxygen. Don't forget you have a cell like this. Okay, an electrochemical cell. Okay, I did not make mention of this, but let me quickly chip this in. I will soon close. Let me quickly chip this thing. In an electrochemical cell, you have 2 compartments. But in an electrolytic cell, you only have 1 compartment. So in an electrochemical cell, you have the cathode in 1 compartment. So you have the electrolyte. And then you have the cathode here. And then you have the anode in another compartment. Then you have salt bridge joining the electrolyte, the first electrolyte to the second one. This is the salt bridge. But in electrolytic cell, you only have 1 compartment. So the anode, both electrodes, both the anode and the cathode, they are in the same compartment for electrolytic cell. But in an electrochemical cell, the electrodes are in different compartments. So you find the cathode in 1 compartment, the anode in the other compartment. So normally, the cathode is usually at the right hand side and the anode is usually at the left hand side. So it is salt bridges this is the salt bridge. It's a U-shaped tube that join the compartment together. The function of the salt bridge is not to mix the solutions together. No, the function of the salt bridge is to allow the movement of ions from one electrolyte to the other. So now we are talking about polarization. Polarization as a defect of a primary cell. There will be hydrogen bubbles formed around the cathode of the cell. When hydrogen bubbles form around the cathode of the cell, what they do is that they plate or they cover the electrode from reacting with the electrolyte, thereby making ions not to flow through the salt bridge to the other electrolyte, to the other compartment. So what can you do to correct it? Since these are hydrogen bubbles, that means if you bring in oxidizing agents, they can oxidize the hydrogen to form water. So when you form water, water can be removed from the compartment and then the electrode will be okay again. So you can use depolarizers such as potassium permanganate, KMNO4, to oxidize this hydrogen to water, and then the water can be removed. So they can ask you that what are the defects of primary cell? The two defects of primary cell are what? Local action and polarization. The ones that involve the formation of hydrogen bubbles is what? Polarization. So basically, this is what redox reaction is all about. Reduction and oxidation occurring simultaneously, and then they form the mechanism of reaction by which all these electrolytic and then electrochemical cells work. Electrochemical cells work. So before I round off, let me give you this. There's something we call Faraday. Although it's the name of a person, but it means a term in chemistry. So if we are talking about Faraday of electricity, a Faraday of electricity is the minimum quantity of electricity required to liberate 1 mole of an electron. One Faraday is the minimum quantity of electricity required to liberate 1 mole of electron. So now, let's say you have something like this. Let me say at the cathode, let's use copper. Let's say CuSO4. This is an electrolyte. In this electrolyte, you find Cu2 plus. Cu2 plus as a metal, if it's at the cathode, it's going to undergo reduction. So you are going to see this form Cu2 plus. This one, Cu2 plus, it means that it has lost 2 electrons. So to make it a neutral atom, it's going to gain 2 more electrons. 2 electrons. So you have 2E minus to give copper solid. Now, you can see that to liberate 1 mole of a copper solid, like 1 is here, but it's invisible. To liberate 1 mole of copper solid, you need how many electrons? 2 moles of electrons. That is to say, to liberate 1 mole of copper, you'll be needing what? 2 Faradays of electricity. Don't forget definition. A Faraday of electricity is the minimum quantity of electricity required to liberate 1 mole of an electron in electrolysis. Now, look at this. For copper, to liberate 1 mole of copper, you need what? 2 electrons. And that 2 electrons, they correspond to what? 2 Faradays of electricity. Now, for aluminium is like this. Aluminium is Al3 plus. You know, it's on group 3 of periodic table. So 3 plus. To liberate for Al3 plus, for aluminium to become neutral, that means you need 3 electrons. 3 plus, that means it has lost 3 electrons. Then you need to give it 3 electrons for it to become neutral. To give aluminium solid. That means that here, you need 3 electrons to liberate 1 mole of aluminium. That is to say, you'll be needing 3 Faradays of electricity to liberate 1 mole of what? Aluminium. And then 1 mole of aluminium weighs what? Weighs 27 grams. Then you can say 3 moles of electrons are needed to liberate 1 mole of aluminium. Likewise, 3 moles of electrons are required to liberate 27 grams of aluminium, because 1 mole of aluminium weighs 27 grams. And then 1 Faraday is equal to 96,500 coulombs per mole. So wherever you see 1 Faraday, it means 96,500 coulombs per mole. So in your JAMB, they will give you this value. So now, to liberate 1 mole of aluminium, that means you'll be needing 3 Faradays. That is to say, 3 times 96,500 coulombs per mole. So they can give you questions and say that, okay, if you have an electrolyte that contains aluminium, maybe Al2O3, this alumina, how many electrons will you be needing? Just write this out, and then you can get number of moles of electrons to liberate each mole of the neutral atom. So having said all these things, I believe if you go through and then read up and then solve more questions on this topic, you'll be able to have an edge over others in dealing with what questions that are of this nature. So this will bring us to an end of redox reaction, that is reduction and oxidation. Do well to go over this video like maybe you just repeat it maybe around 3 to 4 times, because the more you go over, the more you comprehend everything that I've explained here. So I pray that as you go forth in studying, the Lord will help you in the name of Jesus. So we are here based on the initiative from CMRC, that's Creative Mind Royal Concept, and there is a privilege to give, like, to impact students. So I was once a student, like doing, like sitting preparing for JAMB like you. So we thank God for this initiative. So make sure you maximize this initiative very well by studying well, and then making sure that you solve a lot of past questions, because I do tell people that the more you solve past questions, the more you have the knack into solving new questions. It's not that you'll be seeing they'll be repeating the questions for you. No, but when you've dealt with a lot of past questions, it gives you that kind of initiative. So, like by default, you can see another question, and then you know the technique to use to solve the question. So that's that over redox reaction. So we've tried this method. I have tried it before because last time I did my JAMB, that was in 2020. That's the time I did my JAMB that time. And then, glory to God, I was able to pass in chemistry. So in my first JAMB, I had 78 in chemistry. I was in SS3 then. But by God's grace, when I did the second one, I was able to have a 99, like 99 in chemistry. So it's possible for you. So you too, you can do better. You can do better. So I pray that the Lord help you. So make sure that in your reading, make sure that you pray too. So it's only God that can help you. It's not just about you reading. It's not just about spending hours. It's about being aligned. Study very well, and then hope that, trust in God that He will help you. See Him as the word, the sole provider of knowledge. So it's the one that will grant you that intensive memory. It's the one that will grant you the mind that comprehends, that can interpret questions and give the right answers. It's the one that can give you speed. It's the one that can grant you speed. So I pray that as you continue, the Lord bless you in the name of Jesus. So all thanks to CMRC. So all thanks to you guys for listening. You have made me have a wonderful time with you. And I pray that the Lord bless you even as you continue the reading in Jesus' name. So I remain Folaranmi Israel Olaoluwa. So your marvelous chemistry tutor. So do well to have a nice day and enjoy yourself. Thank you very much for your time.
Be sure to link up with us, message us, seek out for our email, send us messages for further questions and mentorship after you have seen these videos. I'm very happy to say this again, that it's a time for you to move on and succeed. It's a free success project 2025. Bless you everywhere that you are. Again, my name is Emmanuel Aderoju Adeyemo from Creative Minds Royal Concept.